I've left space here because we're going to be putting stuff into it. Want to talk about our little friend, the equal sign. Equal sign states that the overall value, whatever is here, has to exactly match the overall value of what is there. So it would be totally right for me to say 8 has exactly the same value as 8. Well, it's an obvious statement really, but yes, it is. But I can split 8 up into two numbers, which when added together would give me 8. So let's do that. Let's get rid of that 8 on the left. And we're going to add a couple of numbers. And I'm going to pick on 3 and 5. So when we apply that operator onto this number in relationship to that, we end up with 8. 3 and 5, when they're put together, this means put together, gives us the overall value of 8, which exactly matches, exactly matches the overall value on the right. So 3 plus 5 is equal to 8. Yeah, you're used to seeing that, obvious you say. Let's hide the 3 for a moment. Now we're getting into the realms of algebra, where we have an unknown value. We know it's 3, alright? We know it's 3. There's a value there which we can't see, which, when we add 5 to that unknown value, the overall value on the left exactly matches the overall value on the right. Now, instead of using boxes, look, it's still there. You can see it's still there. Instead of using boxes to hide the number, suppose we use a letter. Instead of having a box there, what should we go for? Let's put that, there we go. So we have a letter there. Now the letter represents a number. On its own, it could be any number. But because we put that with the 5, with an addition, it fixes the value of A. The value of A is absolutely fixed because we got the equals. It's saying that this lot here must equal the 8. So the question is, mathematically, how do we manipulate this to show that the value of A is in fact 3? We need to be able to manipulate that. Now, there are methods which I'm going to show you. This is the first of several methods. We're going to do addition, subtraction, multiplication and division. We're going to use those operators. This is called an operator. It carries or forces something to happen. Right? So we're now going to be investigating how to deal with addition and finding out the unknown value. Splitting the work area in two. Here we go. This side I'm going to use numbers. This one the algebra. And they're going to be representing exactly the same thing, so you can see what's happening with the numbers and compare it to what's happening with the use of letters. We had 3 plus 5 equals 8 as the numbers. On the algebra, A representing the unknown value plus 5 equals 8. Now these two are exactly the same thing. Right? So the A is just saying there's a number there, we don't know what it's worth. Because these are low values, in our mind we can say, oh, it's 3. But let's just ignore that, don't go down that path. We don't know what that is. The objective is to end up with A equals something here, and we know it's 3. It's saying the value of A, there's the A value, we don't know what it is, and the unknown value is 3. That's the condition we should have. There should be a single number there, and it's saying that A is the value of that number. So we need to have that on its own. We need to have that on its own. If it's on its own, it means we need to remove the 5 or change it such that it has no effect whatsoever when we add. Now, if you have a value, suppose we had 75 and we added nothing to it, it would not change it. So we need to be able to change the 5 into 0. Right? We need to change the 5 into 0. Get rid of that. So how do we do that? Well, this is why I use the term put with for add and remove for subtract. We need to remove the 5. So by numbers only, changing the colour, we do that. That removes the 5. Now, because we changed the left as the equals, we remove 5 from the left. We also have to remove 5 from the right. So that becomes 0. Here is the A plus the 5. Leave a space. There is the 8. Change the colour, and we have removed the 5, remove the 5. What you do to the left, you do to the right. That becomes 0. This becomes 3. This becomes 3. So what we end up with now, just change colour totally, shall we? We end up with the 3 plus, this is changed to 0 to nothing, equals 8 remove 5 is 3. A plus, this has become 0, equals 8 remove 5, which is 3. So we end up here, look, 3 equals 3. I've done exactly the same method on the left as I have on the right. This is true. 3 does have the same value as 3. Here, this now becomes just A equals 3. So it's shown us that the value of the hidden value of the hidden number is in fact 3. So we can substitute in there the value of 3. So end up with 3 plus 5 is equal to 8. This here is the whole point of what I've just done. It has shown you a method of finding out the value of the unknown. If for addition, and the same is true for subtraction, to remove something, you change it to 0. Right? Let's do the same thing but with subtraction. Making something up. Suppose we have 10 remove, they are not subtract, I've said remove 7. Well, the answer to that is 3. Okay? So we have here unknown value A, remove 7 equals 3. These are the same thing. That represents an unknown value which, when we subtract 7 from it, it leaves the value of 3. We want to get that on its own. So by numbers, we want to get that on its own. So we need to get rid of the 7. We need to change it to 0. There's the 10. There's the remove 7. Leave a space. There's the 3. Here's the A. There's the remove 7. Space 3. Change colour. We want to get that 10, that A, on its own. So we need to get rid of the 7. The 7 is subtract. The reverse operator of subtract is add. So what we've done to the left, we do to the right. To make sure that this is still true, we add here, add there, which makes the equals true. This now becomes 0. This now becomes 0. So, changing colour, what we have here is 10 put with 0, so we can change the sign to plus. Put with 0 is equal to 3 plus 7 is 10. A put with nothing, 0, is equal to 3 plus 7 is 10. So we know that the value of A is equal to 10, which matches this one here. Here it says 10 is equal to 10, which is absolutely true. If you're not sure of how something behaves, use low value numbers and watch how the things react with each other. Test things out, okay? So that is addition and subtraction algebra introduction.